Okay, please download the RIP version 1 slide. Okay, so these are the topics that we are going to cover in today's lecture or Wednesday's lecture. So basically the RIP version 1, and the first today on Monday, we are going to configure this router R1, R2, and R3 based on this topology. And these are the IP addresses that we are going to use. And the RIP version 1 is a distance vector routing protocol, and it's also is known as it is actually a classful. It's not a classless, it's a classful routing protocol. Okay. So RIP version 1 is still used today. As you can see, RIP version 1 is a classful and RIP version 2 is classless. It's a distance vector routing protocol. The metric is hop count. Okay. So this is the message format exchange or the routing update message format. Okay. So this is dynamic routing protocol. So there is the update messages, but it is there are a lot of update messages that's exchanged between two routers. So if you look at the RIP message format, of course, this is IP packet, so you have an IP header, and then there's a RIP message. And if you look at this entry, there is a field that you can specify IP address, but there's no field which you can specify subnet mask. So no subnet mask information is embedded in the RIP message. So R2 when a router receives a RIP update and with a network address, and this router adds a network address and a mask to the routing table. Okay, but the problem is that if you use the RIP version 1, since there is no specific mask information embedded in the routing update message, R2 had to make an assumption. Okay, either you're going to use a subnet mask used in this interface. In this example, it's a /24, even though this is class B, so we're going to either use /24 as a mask, network mask, or we're going to use a typical classical subnet mask. When this network address is class B, then we're going to use /16. If this network address, if the RIP update with the network address, if this network address is class C, then we're going to use /24. So because of these limitations, RIP version 1 network cannot be discontinuous. We'll talk more about this later on. Or they cannot, nor can they implement VLSM. So today, we are going to configure this. We're going to configure RIP version 1 on R1, R2, and R3. This is a scenario that we are going to use. So we have a class 5 class C network address. And, the first one, second, and third, and fourth, and 5. So we have a 5 class C network. The first one is 192.168.1.0. Next one is 2.0, 3.0, 4.0, and 5.0. Okay. And this router RIP is a command to configure RIP version 1 routing protocol on R1. Okay. And then if you do not if you do not want to implement, or if you want to nullify or cancel the previous RIP protocol, you can simply type no router RIP. And this network command called network is going to enable the RIP routing for a network. So you're supposed to enter classical network address for each directly connected network. So in this case, let's look at the R1. Okay, let's look at the R1. R1's this router has two directly connected networks. One is 192.168.1.0. Yes, so that one network. It has another directly connected network, right, which is 192.168.2.0. Right, so there are two networks. So that's why we have to have the 1.0. So you have to say network. And then you have another one here. So we have to say network 192.168.2.0. So this network commands perform the following functions. Enables RIP on all interfaces that belong to the specific network. In this case, and then the next one is, so the first one is enable RIP protocol on all interfaces that belong to a specific network. In this case is 2.0 and 1.0. And advertise the specified network, meaning 1.0 and 2.0. And the RIP routing updates sent to the other routers, in this case is R2, every 30 seconds. Every 30 seconds, it sends the routing update messages to R2. And if you look at that update messages, it contains that routing update message. That message contains two networks. One is 1.0 and next one is 2.0. So for R1, it has a two directly connected network. And for R2 has what? Three connected, directly connected network. And then R3 has two directly connected networks. So even though you type, let's say, specific IP address like 32, the router will convert it to the network address, which is 1.0. So so let's look at the R2. R2 has 2.0, 3.0, and 4.0 as its directly connected network. That's why you have to type 3 network command. Okay. So let's take a look at the. So once you finish configuring the RIP version 1, you can type show IP route. Okay. This 120 means the admin distance. Okay. And this 2 is a metric, so this means 2 hop count. So from R3 to get to this 192.168.1.0, that's a final destination network. It takes 2 hops, and that packet has to send to this interface. Okay. So let's using a post-nesting. Okay. Let's build a topology, and then we're going to configure RIP version 1 routing protocols on R1, R2, and R3. Let me stop recording my lecture.